The tools we have to prepare are the ring magnets, the circular magnets, the U-shaped magnets, the bar magnets, and the paper clips. We use the bar magnet to attract the paper clips one by one to measure its magnetic force. We are going to attract one paper clip to one end of the bar magnet. Then we try to get the second one. We got the second one. Then we try to get the third one. We found that we cannot really get the third one. Next, we try this with the other end. We attract one paper clip first. Then we try the second one. We got the second one. Next, we try to get the third one. We find that we cannot really get the third one. So for now, both two ends of the bar magnet can attract two paper clips. Then we try the middle part to see whether we can attract the paper clip. Let go. Then we find that the magnet cannot attract the paper clip. Since both ends of the bar magnet can attract two paper clips, the middle part cannot attract any paper clip. That means the magnetic force at the two ends is stronger than the middle part. Then we use the U-shaped magnet to attract paper clip one by one to measure its magnetic force. First, we put the paper clip at one end of the magnet. It can attract two paper clips. Next, we will try the other end. Two paper clips. Neither two ends can attract the third one, so both ends can attract two paper clips. Let us try the middle part of the magnet. See whether the magnet can attract the paper clips. Put the paper clip in the middle. We find that it just fell off. So the magnet's middle part cannot attract paper clips. We can see that two ends of the magnet can attract more paper clips than the middle part, so it means the two ends' magnetic force are stronger than the middle part. Next, we use the circular magnet. We put the circular magnet onto the pile of paper clips. Then, we can see that many paper clips are attracted by the magnet. We cannot judge the magnetic force of a circular magnet in this way, so we use the magnet to attract the paper clips one by one. We put one paper clip on one side, then try the second one. The third one. We find that the third one cannot be attracted. Let us try the other side. We try the first one, then the second one. The third one. We find that both two sides can attract two paper clips. Next, we're going to try the middle part. The circular magnet's middle part is on the curved surface. Let us try it. Now we put the paper clip onto the middle part. See if the magnet can attract it. Put it down and let go. We can see that the paper clip we just put in the middle moves to one side. Let us try it again. We find that it moves to one side again. It means that magnetic forces of two sides are stronger than the middle part. Finally, we put the ring magnet onto a pile of paper clips. The same, we can also see it attracts many paper clips. We cannot judge the strength of its magnetic force this way, so we take the paper clip down first. Then we use the magnet to attract the paper clips one by one to measure its magnetic force. We do this side first. It can attract one paper clip and can attract two paper clips too. For the third one, we find that it cannot be attracted. Next, we switch to the other side. We try the first one. Next, let us try to see if we can get the second one. We got the second one. The third one. The third one cannot be attracted. Now we know both two sides of magnet can attract two paper clips. Then we're going to try the middle part. Part in the same position is on the curved surface. Let us try it. We put the paper clip in the middle of the curved surface. Then let go. We can see that the paper clip moves to one side. Let us try it again. Put the paper clip in the middle part. Then let go. We can see the paper clip moves to one side. So we can know that the magnetic force is stronger at the two ends than the middle part. Next, we can make our own iron powder case. The tools we need are scissors, tape, transparent petri dish, iron powder, circular magnet, ring magnet, bar magnet, and U-shaped magnet. First of all, open the petri dish. Then pour the iron powder into the petri dish. Once it is done, cover the bottle's lid back immediately. Then we also put the petri dish's cover back. Take pieces of tapes. Attach the left and the right side. Once it is done, use the tape to seal the gap around the petri dish. Please be careful when doing this. Ask students to do it on the desk, or the whole dish may easily be knocked over onto the floor. When taping, it is more secure if we wrap it twice. Then the iron powder will not leak as easily. Make sure all the gaps are sealed. Our own iron powder case is done. You can use different shapes of magnets to do the experiment. Let us try the bar magnet first. We can see that no iron powder was attracted or moved. Next, we use the U-shaped magnet. Then we can see that some iron powder moved when we test the U-shaped magnet. But it is still not attracted. Then we use the circular magnet. Once we have put the circular magnet on the case, we can see clearly that some iron powder got attracted. What will happen if we put one more magnet on it? Let us put it on. As the magnetic force becomes stronger, the evidence is that more iron powder got attracted. Then let us use the square magnet to try it. We can see that almost all the iron powder got attracted. Next, let us try the neodymium magnet. We can see that neodymium magnet has attracted all the iron powder, even the iron powder case too. So the more iron powder gets attracted, that means the stronger magnetic force magnet has. For attracting and repelling experiment of different magnets, we have prepared the balloon stick, the holder, circular magnet, ring magnet, bar magnet, and U-shaped magnet. First, we take 2 bar magnets for the test. We can see that the bar magnet has 2 poles. The blue part is S pole and the red part is the M pole. We place the blue parts of the 2 magnets close to each other to give it a try. Put 2 S poles close to each other with one placed stationary on the table, the other one is moving. We move one of the bar magnets. We can see that the stationary ones S-pole suddenly moved a bit. Let's see it again. It moved away. The two of them will repel each other. Then we place the two end poles facing each other, just like earlier, one placed on the table. We move the other bar magnet. We move this end pole slowly forward. See what happens. We can see that this end pole that was not moving suddenly moved. Both will repel each other. Then we get the blue S-pole close to the red end pole in my hand. Try it and see if anything different happens. When taking the end pole slowly towards the S-pole, we can see that they have been attracted to each other, so we can know that the same pole will repel, different poles will attract. Next, we use the U-shaped magnet for the test. The U-shaped magnet is the same, the blue side is S-pole and the red side is N. First, we put them with the same color together. Let us try and see what will happen. First, we see red to red, blue to blue. Once placed on the table, one move forward after moving slowly forward. We can see the stationary U-shaped magnet moved backward. It may even move towards the side and the blue is facing on the red. Then we flip it around. Blue face to the red, make the S-pole face the N pole, the other N pole facing on S-pole. Place the magnet on the table, do not move it. The other magnet is moving close. Let us see what will happen. Move the magnet slowly forward to get closer. We can see the two magnets have attract each other. The S-pole attracts the N pole. The N pole attracts the S-pole. So the same poles will repel and different poles will attract. Let us check another kind of magnet. Then we use the ring magnet. Set the red side of the ring magnet facing the front. Fix it onto the table. Then we move the other ring magnet and make red side go slowly forward. We can see that the magnet on the table will move backward. It's moving backward means that they will repel each other. Next, we will switch to the blue side facing the front. The same, we make the red side facing the front move forward. Let us see if there will be any differences. After moving forward, we can see the blue side will move towards the red. So, they can attract each other. Then, similarly, we can see the same poles will repel, different poles will attract. If we come across an unknown magnet and do not know which of its side is the N pole and which is the S pole, we can use another magnet that we know about to do the test. First, we make a mark on this unknown magnet. Once marked, we take the red side N pole to approach it. After approaching it, we can find that the magnet moves away, so these two poles repelled each other. Since this red is the N pole, that means the side we mark is also an N pole. Now we use the S pole to see if they will attract. After using the S pole for the test, we found that they have attracted each other, so we know which of its side is the N pole and which is the S pole. And the marked side is the N pole and the unmarked side is S pole. Now we're going to do the levitated magnet. We prepare 2 straws, 2 holders, and ring magnets. We put the holders and the straws together. We need to put together 2 sets. We insert the straw into the holder. Insert the other one. After both have been inserted, we have the red side of the ring magnet facing down. Put one down for each. Once down, we can see that both have the blue side facing up. Next, we will try to have the different side facing down. For this, we will place it down with the red facing down. For this one, we will have the blue side facing down. Now, try and see what is different between the two. You can see that these two magnets have attracted each other. For this side, the two magnets did not attract each other, and the magnet at the top is floating. What is the principle at work here? That is, the opposite poles attract at work. Then these two here are the similar poles repel. If we want to make every magnet that is at the top to levitate, how can we do it? We can see the red side facing up is already levitating. So we make the red be the similar pole and face each other. That makes it levitate. Next, you can see that the blue side is facing up. Let us find another blue one and make them face each other. In this way, we will have 3 levitating magnets. This is the application of the principle of similar poles repel, allowing a magnet to levitate. For this that is attracted together, we apply the principle of opposite poles attracted.